go. Hello, this is our video for the MEC 2502 project. My name is MD Zarif Majumdar.
My name is Gavin Leslie.
My name is Wakila.
And there's also Ahmed Lakhani, who is not here with us right now. So the problem we decided to tackle was how to create a more environmentally friendly way of heating up water. So the solution that we came up was to try and create a solar collector. So the way it's going to work is it's going to pump unheated water into the system and pump pump heated water out of the system. Another function is that it's going to rotate to keep, as the sun rotates, the light will change, so it's going to rotate to keep up with the sun. Another thing is to demonstrate, it's also going to have a way to pump out hot water after it reaches a certain fluid volume. It's going to pump hot water out of the system, and the data that we're going to be acquiring is going to be temperature data, the angle that the mirror is shifting over the day, the fluid volume that it's going to be outputting, as well as the intensity of the light that is hitting the collector.
Our objectives for what we're trying to measure using this solar collector is, first off, we are trying to measure the light intensity of the sun as it is hitting the mirrors. This is so that when the sun changes its positioning, we can then change the angle of the mirrors, which we will also be measuring to match that so that the mirrors are getting the most light intensity. This is so that we can measure the water temperature of before and after it goes through the solar collector. And then that water, the heated water and the cold water, will be stored in tanks, which will then also be measured using a pressure transducer.
So for the building blocks of our system, we're going to be needing two temperature sensors, RTD sensors, that will measure the water of the hot and the cold tank, two pressure transducers to measure the volume in both of the tanks, and of course the two tanks. We're going to be needing two sheets of metal or mirrors that will reflect the light into the tubing, and the tubing as well, which the water will be running through the tubing and being heated by it. We're going to be needing a motor and encoder, which will control the angle of the rotation of the metals or mirrors, a pump to pump water in and out, data acquisition to get all the data that we're going to require to run it, a signal conversion to convert, a lot of the sensors, they run on volts, and we're going to convert that data into stuff that we can more easily understand. We're going to calibrate the sensors as well, and a signal amplifier to help power all the sensors and connect them with the computer and all that.
Here are the sensor and actuators that we are going to use in our system. First, the RTD. The RTD measure the temperature using the resistance, which changes with the temperature, and it will help us measure the heat in the water. The pressure transducer, which is measure the pressure through the fluid volume. It means that the more volume in the water, the more pressure in the water. So next is the motor and encoder. The encoder will help us measure the angle to find the best angle to reflect most of the light, and the motor is used to rotate the collector. The photoresistor, we measure the intensity of light which is hitting the collector. The higher resistor is the lower the light intensity. And lastly is the pump, which pump the water in and out of the system.
Some potential applications for this in industry would be seeing if the solar collector would be able to produce enough heated water that it could replace a boiler in a Rankine cycle, or perhaps a boiler in a person's home, providing enough heat. A scientific application could be that measuring how light intensity has changed due to climate change. And by having that light intensity heat up water, it could be used to see how bodies of water, such as lakes and oceans, are affected by this change in light intensity.
Okay, here are our sources. Thank you for watching. Thank you.